So now let us come to another property of a parallelogram, which helps us prove that the parallelogram is indeed a rhombus. So the property states that if the diagonals of a parallelogram are perpendicular to one another, or in other words, if the diagonals of a parallelogram are perpendicular or intersect at 90 degrees to one another, then that parallelogram is a rhombus. So let us try and prove this particular property. Over here we have been given that ABCD is a parallelogram, and we have to prove that ABCD is actually a rhombus given that they are intersecting at right angles. So we have to prove that AB is equal to CD is equal to AD is equal to BC. That is, all four sides are equal to one another. And we have been given that ABCD is a parallelogram, and also that AC is perpendicular to BD. This is what we have been given. So now let us see how we can proceed with the sum. So in order to prove that this is a rhombus, we first consider two triangles, triangle AOD and triangle COD. That is, this triangle and this triangle. So in these two triangles, what can we say from what has been given to us? As is clearly evident, we can say that OD is a common side in between these two triangles. So I write OD is common for these two triangles. Further, what can we say? We can say that this angle is equal to this angle. Why? Because we have been given that the diagonals are intersecting at 90 degrees. So thus I can write angle AOD is equal to angle COD, because both are 90 degrees, since it has been given to us that AC is perpendicular to BD and these two angles are linear pairs. So since the sum of both will be 180, and since they are equal, each is 90 degree, thus AOD is equal to COD. Lastly, what can we say? We can say that since this is a parallelogram, we know that their diagonals will bisect each other. Thus, OA will be equal to OC, because the diagonals of a parallelogram bisect one another. So I write OA equals to OC. So now we have one side that is common, two angles that are equal, and another two sides that are equal to one another. So if you look closely, you will find that these two angles are included angles, or in other words, it is included in between OD and OC, that is this angle, and this angle is included in between OD and OA. So what can we say? We can say that triangle AOD is congruent to triangle COD through the side angle side rule of congruency. Thus, these two triangles are congruent. Now let us see what we can say about these two triangles. Since these two triangles are congruent, I can say AD is equal to DC. I write AD is equal to DC. Why? Because these two sides are corresponding parts in two congruent triangles. So through CPCT, I can write AD is equal to DC. So I have AD equals CD or DC. Now it has been given to us that ABCD is a parallelogram, and in a parallelogram we know that opposite sides are equal to one another. So the moment I write AD is equal to DC, and if I consider the opposite side of DC, I have BA. Now since opposite sides are equal, I can write DC is equal to BA, or this side is equal to this side. So AB is equal to CD, or DC is equals BA, because opposite sides of a parallelogram are equal. In a similar manner, I consider the opposite side of AD. The opposite side of AD is BC. So I can write AD is equal to BC. I write AD is equal to BC. This also I am able to write because opposite sides of a parallelogram are equal to one another. So I have AB is equals CD and BC is equals AD. And through congruency, I had proved that AD is equals DC. So finally, what can I say? Using all these equations, I can finally write that AB is equal to BC. That is, AB is equal to BC equals CD equals DA. That is, all four sides are equal to one another. And this is exactly what I had originally set out to prove. I had originally set out to prove AB is equals CD equals AD equals BC. And this is exactly what I have proved, that all four sides in this parallelogram are equal. So in other words, it is a rhombus. So now let us study about the special properties that are exclusive to a rhombus. We have studied about these properties which are true for a rhombus as well as a parallelogram, because a rhombus is also a kind of parallelogram. Now we have these three properties that are exclusive for a rhombus. All sides of a rhombus are equal. Diagonals of a rhombus intersect each other at right angles. Diagonals bisect the angles of a rhombus. And these properties are exclusive for a rhombus because it is a special case of a parallelogram. So in addition to these properties, a rhombus has these properties as well.